So our first section in our unit of work on digital download and file storage is talking about the basics of our units of storage and the language around that. So this is something that you see all the time and you hear all the time in your everyday life, because all digital devices such as computers, iPads, tablets and mobile phones store data in digital form. So this unit of storage of this digital form you talk about and hear about all the time. So we're talking about the maths behind it, the things you might not know. So our zeros and ones, for example. Our zeros and ones are called our bits. So a bit is the smallest unit of data stored in an electronic device and is abbreviated as a lowercase b. So our bits are our zeros and ones. Now that's about all you need to know for the syllabus. However, Khan Academy does a great explanation on what a bit is and the zeros and ones and the base 2 that they are in. I won't play this, it goes for 10 minutes, but you don't need to listen to it all. But even just getting some concept of what a bit is and the zeros and the ones and what it represents. Okay, so that's very useful for you to get a really good understanding of everything to do with units of storage and digital downloads and bits and bytes. Okay, so that's very useful. So now going to our byte. So a byte is a group of 8 bits that represent a single unit and is abbreviated as a capital B. So bits, little b, bytes, capital B. Data is usually measured in bytes. So we hear this all the time. So it's about, what plan are you on with your mobile phone? How many gig do you have in storage? How many bytes is this file? What size music download is that? Is it a meg download? Is that movie that you're trying to download? A gig? Have you got enough room for it? These sorts of language you talk about and hear about all the time. So once again, we're learning about the maths behind it. So we've got our units here. Our bytes is our smallest unit, then our kilobyte, megabyte, gigabyte, and our terabyte. And they're abbreviated by capitals. So capital B, capital KB, capital MB, GB, TB, etc. Now our meaning is, we think about it in terms of kilo. We always know like a kilogram, for example, is 1,000 grams. So a kilobyte here, we're talking about 1,000 bytes. But it is not as simple as that, because it is in base 2, not base 10, which is what kilos is in. So you learn more about base 2 with that Khan Academy lesson. However, just being simple is that we're not timesing by 1,000 this time, every time we move on. We are actually timesing by 1,024. And let's have a look why. So we've got 1 byte is just 1, so it's 1 byte is 1. But 1,000 bytes or a kilobyte is 2 to the power of 10, which is not 1,000, but let's have a look. 2 to the power of 10, it is 1,024. So instead of looking at everything as 1,000, we're actually looking at everything being multiplied by 1,024. So you can think about it in power 2, or you can just think about it as multiplying by 1,024, which I find easier. So if we're now looking at megabytes, how many bytes in a megabyte? Yes, we think of it as 1,000,000 bytes, which usually, okay, is 1 with 6 zeros. However, base 2 means 2 to the power of 20. So we can do this one of 2 ways. We can do it 2 to the power of 20, which equals, so it's 1,048,576 bytes. Or we can think of it as multiplying by 1,024 instead of 1,000. And that gets us to that same answer. So we're talking about 1,048,576 bytes. So similarly, if we did that again with the gigabytes, 2 to the power of 30 in the calculator, or 1024 times 1024 times 1024, we would get 1 billion and this very, very large number. So you never obviously need to remember these numbers. You just need to remember that you're multiplying by 1024, or if you prefer, remember the powers. Now you'll notice when we do a trillion, it is 2 to the power of 40, which the answer comes out in scientific notation. You can write it in scientific notation, that's fine. Okay, or the long full answer, which I received from a different, which actually is in your textbook. Okay, we're talking about 1 trillion and then all these numbers that go behind it. But once again, you don't need to remember that. You just need to remember it's multiplied by 1024. So in our next section, we'll look at converting in between bytes and kilobytes and megabytes and gigabytes. And then later on, we'll look at converting those back to bits, remembering that 1 byte is 8 bits. So we'll go on to the next lesson.